Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, Mallar Institute of Technology, Hyderabad. As part of data mining video lecture series, so in this lecture we are going to discuss mainly the requirements for cluster analysis. So previous lecture I gave introduction part of cluster analysis. Now in this we are going to discuss mainly the requirements for clustering and the aspects for comparing the clustering methods and what are the different aspects we will use here. So if you see the typical requirements of clustering, mainly the scalability, that is, and the ability to deal with the different types of attributes, discovery of clusters with arbitrary shapes, not like a spherical, and requirements for domain knowledge to determine the input parameters. One important input parameter is the number of clusters, and the ability to deal with the noisy data. If your data set has a noisy data, then how we can deal with that. Next, incremental clustering and intensity to input order, capability of clustering high dimensional data, constraint based clustering, and interpretability and usability. So let us see one by one the requirement. Mainly the scalability is one of the important requirement. So many clustering algorithms as well work well on a small data sets. That is, the data sets containing very few objects. As I said many times, the real world data has the real world data sets. Any data, if you take any real world data, each data set would have a large number of data objects. So like a large database may contain millions or even billions of objects, particularly in the web search scenarios, etc. So we need a scalable clustering algorithms, that means which can work perfectly or which can do the clustering on the large number of data objects. The second requirement is ability to deal with the different types of attributes. As we discussed in the previous lecture, that is a k nearest neighbor, like categorical, the nominal attributes, categorical attributes, and I already explained the different types of attributes in the lecture number 5. So you can also go back to that and you will understand what are the different types of attributes. So how we can deal with those attributes. So that is one of the requirement in this clustering analysis, that is to deal with the different types of attributes. So many algorithms are designed to cluster the numeric interval based data. However, but as I said, many real life applications may require a clustering other than other data types such as a binary, nominal, categorical, ordinal, or mixture of these data types. So the more and more applications nowadays need clustering techniques for complex data types such as graphs, sequences, images, and documents. So this is another the requirement for the clustering. Next one is a discovery of clusters with arbitrary shapes. So it's very important to develop the algorithms that can detect the clusters of arbitrary shapes, like previous examples, like when we discussed about the clustering, we used to discuss the shapes like spherical shapes, but there are different shapes, like you can see from this diagram, like a half kernel, the two spirals, and outliers, aggregations, corners, cluster in cluster, crescent, full moon. Like these are the different shapes. So we have to develop different clustering algorithms that can detect the clusters of this kind of arbitrary shapes. So next one is the requirements for the domain knowledge to determine the input parameters. So here the requirements for the domain knowledge, like what are the input parameters. If you take, as we discuss this, we are going to discuss k nearest neighbor. Sorry, that is a classification approach, and the k means and k medoids. So these are the clustering algorithms. What are the parameters? So we will use the different parameters for each algorithm. So we need to have a complete understanding of those parameters. That is one of the main requirement, that is to have the domain knowledge to determine the parameters. Like suppose if you take the k-means, that we will discuss in coming lecture in very detail. The k-means is the number of clusters. How you can specify this parameter, that is number of cluster, k value, unless until you have the domain knowledge, then we cannot just simply select a random k value. Next one is the ability to deal with the noisy data. As I said, the real world data, most of the real world data would have a noise in it. So we already discussed like how to deal this noisy data, how to remove the noise, etc. So most real world data sets contain outliers or the missing, unknown or erroneous data. For example, if you take a sensor readings, these are often noisy because some readings may be inaccurate due to the sensing mechanisms, and some readings may be erroneous due to the inferences from the surrounding transient objects. So clustering algorithms can be sensitive to such noisy and may produce the poor quality clusters. So therefore we need the clustering methods that are robust to the noisy data. Next, incremental clustering. In many applications, incremental updates, like the new data is continuously arriving. So if the new data continuously arriving, so our algorithm or a clustering algorithm or any other algorithm should be in a position to classify or to cluster the new data. It has to adapt the new knowledge also from this new arriving data. So some clustering algorithms cannot incorporate the incremental updates into the existing clustering structures and instead have to recompute a new clustering from the scratch. Okay, so that means, so once a new samples, new data comes into this, so we have to from the scratch, we have to recompute, we have to compute the clusters again. That is one approach. And if your clustering approach is an incremental clustering approach, so that it can easily update the new data. So clustering algorithms may also be sensitive to the input data order also. So that is, the given set of data objects, clustering algorithms may return the dramatically different clusterings. That is, depends upon the order in which objects are presented. Incremental clustering algorithms and algorithms that are insensitive to the input order are needed. Next, capability of clustering high dimensionality data. So this is another important concept that is need to understand so that we can deal this high dimensional data very effectively. So here high dimension means number of dimensions. Like suppose if you take any data set, mainly we would focus on this number of attributes, and the second priority, the number of tuples or number of objects. So here both the number, like let us say here m number of attributes, n number of tuples. So the data here, this data set is going to have the values, that is m times n number of values. So that those many values need to be processed, or the search space of any algorithm would depends on this m times n. So most clustering algorithms good at handling the low dimensional data. That means very few features. That means data sets involving only the 2 or 3 dimensions, etc. But finding clusters of data objects in a high dimensional space is challenging, especially considering such that the data can be very sparse and highly skewed. What do you mean by sparse data? And what is the problem with this sparse data? Like suppose if you, as I already mentioned in the previous lecture also, like suppose if you take a movie rating, IMDb, if you look at IMDb movie rating data set, then you will find the rating. That means there are different movies, let us say movie 1, movie 2, etc. or the ratings given by the users 1, user 2 and 3 and so on. So most of the values in this data set, IMDb data set, are empty. Empty means there is no rating given by the users. There are many. And if you represent the unknown values with the zeros and the known values, means for which the value, that is a user has rated the movie. So the number of zeros are more. Number of zeros are more. So that means very few number of known values, large number of unknown values. So then that data set is a sparse data set. Another one is a skewed, highly skewed. Skewed, normal distribution, and if the data is skewed, the distribution is skewed, okay, so it is very difficult also to estimate the parameters. Next one is the interpretability and usability. So how are we able to interpret it properly or not? That is another very important. Once, even though you identify the clusters by using any clustering algorithm, how you are going to interpret and how the clusters will be used. Like suppose if you take in a business intelligence, if you segment the data, the customer data, or if you segment the customers into the different groups, and what is the use of that each group? Just simply grouping the customers will not help us, but how, like for example, if you cluster the customers into the 3 groups, let us say like a high income groups, low income groups and a middle, then how we are going to use this one group, that is let us say high income group. So what are the business decisions we are going to take, like that. Like suppose even if you take a call detail records, CDR, so based on this also we would classify the customers into the different segments. So based on that we would recommend, or we plan some that the plans, monthly plans, unlimited plans, message plans or calls, data related plans would be decided. So that is how, whatever the clusters you are going to make and how those clusters would be useful. And another important thing is the interpretability, how you are going to interpret that clusters. Like how, like let us take this segment in this cluster, how you are going to interpret this, and suppose if you take another segment, how you are going to interpret this. So that is another requirement of clustering. Next one is how we can compare the different clustering methods. What are the aspects need to be considered? So there are mainly the 4 aspects need to be considered to compare the different clustering methods. Among those, like a partitioning criteria and separation of clusters, similarity measure, clustering, space. These are the different aspects for comparing the clustering methods. So partitioning criteria, how the partitioning would be done. Like we will discuss different partitioning methods like a hierarchical clusterings. There we will discuss a divisive and agglomerative clusterings, etc. Next, the separation of clusters. How we are going to separate the clusters? What are the parameters need to be considered in order to separate the clusters? And more important thing is the similarity measure. So how you are going to, like suppose we are, as we are going grouping the objects or tuples into the different clusters, how you are going to identify the similarity between the objects. So which similarity measures you are going to use. So that is another important aspect. Next thing is a clustering space. Like, so whether we are going to consider the entire full space or subspace. So most of the time we may not use this full space, so that because that is prohibitively expensive, as we discussed like in the association rule mining, the number of one item sets, the number of two item sets, and then like that, how the such space would be reduced and how complex the costly process that is. Similarly in this clustering also, if we use the complete information in this data set to cluster the objects into the different groups, then we are going to use the full space. So that is very costly. Whereas a subspace clustering, not the entire information would be used from the data set, the subset of information or subset of attributes would be used to perform the clustering, to identify the similarities, etc. So based on all these aspects, we will compare the different clustering methods. So let us quickly summarize what we discussed here. So whatever the factors, like we discussed the requirements mainly for clustering, that includes the scalabilities and ability to deal with the different types of attributes, ability to deal the noisy data, and the incremental updates, clusters of arbitrary shapes and constraints, interpretability and the usabilities. These are all the important requirements for clustering analysis. In addition, we also discussed the aspects to compare the different clustering methods, like what is the partitioning level and where or not to cluster manually, exclusive, then the similarity measures used, and whether we are going to use the full space or the subspace for clustering. So that's it. So next lecture we are going to discuss the k-means.